Hello, everyone. I think the microphone sound, is that okay in the back? Is that too loud? Okay. My name's Bob Mumford. I'm an HP Big Data IoT Solution Architect. I deal with customers quite often with designing Hadoop infrastructure platforms, and we've been getting into the IoT space for a while now. And this session is going to kind of cover our whole pitch from core to the edge, showing you what we envision that looking like and trying to show you how we're innovating in that space. My email is here if you have a need to contact me about this after the after the presentation. I'm also at the HPE booth out on the show floor where I'm covering some of this as well. So if you have questions, either contact me after the session here or you can catch me tomorrow during the show hours. Our SSA at hpee.com box is a drop box. Essentially, if you have any kind of a sizing request for Hadoop, pretty much anything that runs on hardware, we'll try to help you out. If you send a request to that mailbox, we will route it to the solution architects that deal with whatever need you have and try to fulfill that for you. Okay. As you know, most businesses today are having to deal with an influx of data from the edge. That data is being generated by the machines, the sensors, the things out on the edge, right? A lot of times that data is planned for, which is great, but then there's other times that that's not being planned for and you're having data overload, if you will. And dealing with that data is a challenge. And there's a couple areas that we have to address that with. The hybrid IT and the intelligent edge. In the hybrid IT world, you have to kind of envision, is your infrastructure going to be able to handle the variety and velocity of data coming at it? You're going to have to understand, excuse me, I've been talking a lot at the show and my voice is getting a little gone. You'll have to be able to envision, how you're going to handle it. In the intelligent edge, you've got all this new type of data coming in. It used to be in an OT system where the analog data coming into your individual controllers and actuators. Been that way for 30 years, okay? The National Instruments, those guys have that covered. We're not trying to take their place. We're just trying to integrate some of those devices onto ours, consolidate that field, and give you more of an IT edge approach, an intelligent edge, if you will. So we're not the only ones thinking that there's a lot of data coming. Gartner thinks that by the year 2022 that there's going to be from 10% today to 75% more data generated. So if you're having troubles with dealing with your data influx now, it's only going to get worse. So what we're trying to do here is allow for more compute at the edge so that we can throttle that data load from your data center down, take care of more of that at the intelligent edge where it can be handled intelligently, give you quicker insights on your data as well. There are cases, of course, where you can do your analytics at the data center. Your predictive analytics don't require real-time, low service level, low latency isn't a requirement there. That's perfectly fine to be run over there at the data center. Your machine analytics, learning, your data training can take place there and the models developed. And I'll show you a chart here where we push that down to the intelligent edge to do the inferencing there at the edge. And that's really what I'm talking about here at the bottom, where we're looking for more real-time insight moments. These are real-time. This is, in other words, you don't have the latency luxury to send this data up to your data center, have the data processed, have it go all the way back to a monitor out at a plant site. You want that stuff happening much quicker than that, and that's what we're trying to allow for here. This is kind of being developed because our existing data warehouses really aren't suited for anything more than the old ERP type database systems that you're doing your enterprise data warehouse queries on. Now we've got all this new kind of data, and you've got a lot of it. And those enterprise data warehouses aren't really suited for large amounts of data. We're having data protection and governance issues. Now that we're going to be collecting this data out the edge, we want that protection to go as close to the source of data generation as possible. with the existing OT systems that are out there, that's really not a possibility. So we're going to replace that with a system that we can push libraries all the way out to the IoT gateways so that we can protect that data as soon as it's generated. In our existing data lakes, we're really referring here to a traditional architecture of Hadoop, and by traditional architecture, I'm referring to a 2U server that has the combined compute and storage on the same server. That's been the traditional model of Hadoop for years. And all of those servers are going to be the same. Every rack is going to have those 2U worker nodes, and they're all going to be similarly configured. But the problem that kind of leads to, from Hadoop 1 to Hadoop 2, you had Yarn come out, and it promised that you could get more utilization out of your servers by running multiple workloads on these servers, and it certainly accomplished both of those objectives. But the objectives that you aren't seeing there is with those combined workloads, you're now not getting the service levels maybe you have on some of your lower service level agreement workloads, because all of these workloads are fighting over resources. And so you do have all the better utilization and more workloads, but they're not being optimally platformed, and you're not getting the performance needs out of it. And what usually happens is you will set up another cluster for those higher performance systems, and then you start getting into the data replication and all the issues that involves. So that's really what I'm trying to refer to there at the end. Okay, this is the way it's been for a long time. This is the edge that divides IT from OT. This is our view of it. If you talk with a software partner, you're going to probably see a chart with maybe 9 boxes on it. From an infrastructure view, this is how we view it. Stage 1 and 2 is out at the plant, out at the offshore rig, anywhere outside of IT, out of the data center. Stages 3 and 4 are going to be taking place in the data center. And the stages 1 and 2 is what's referred to as OT, or operational technology. 3 and 4 is IT. Okay, and then never the twain shall these meet, or it hasn't in the past. And that's what we're trying to solve for here. What we're going to do is try to look at stages 2 and 3 and see what we can do about pushing some of that IT functionality, some of that IT goodness out to the edge, some of that manageability out to the edge, replace some of that OT with IT, and now then your data center staff is going to have a remote service capability all the way out to maybe the job sites, okay, to the sheds, to the plants and things like that. So what that looks like is we're going to shift it. We're going to shift IT left. We're going to combine stages 2 and 3, and we're going to call it a converged OT system. That's a term that we came up with when we developed the Edgeline system. It's kind of a new nuance of server platform available. What we're doing here is we are now pushing all of the analytics, the Hadoop, the machine learning, and all that's going to stay over there in stage 4. But now then we have servers out there on the edge that are capable of doing much more processing than the old OT systems they're replacing. We're taking these gateways here are going to be stage 1. These are your early analytics, kind of like early ETL, where you're doing some basic decision, or ETL, extract, transform, and loading of the data to decide what goes upstream. These are going to take your actuators and controllers. There's slots in these devices to put in cards from these OT devices, and we've certified them with these products. So what we're doing is we're consolidating all the OT functionality into one box. I've got a slide later that's going to show you all the different methods of wired connectivity, wireless connectivity. All of that can be combined into this one box. And we can do some basic ETL there, decide what to send upstream. And that's going to go up. This stage 2, 3 could maybe be if it's a refinery, maybe it's a control shack out there near the refinery. And that's where your analytics are going to be run. That's where your monitoring stations are going to be. That's where your real-time requirements are being met. Okay, and of course, if this is open source, you're looking at maybe a SMAC stack, your Spark, Meso, Saka, Cassandra, Kafka, whatever your data flow architecture is, it'll be implemented there on site. And of course, in in your IT data center, you'll have a bigger installation that'll be talking to. So this is the device right here. I'd have some better pictures of that, so I'll show you, in case you want to look at that. It's kind of interesting. That box holds 4 of these. The EL4000 holds 4 server cartridges, and this is a server. It has a processor. The M710 even has a integrated GPU on it if you need that for machine learning. This particular one has up to 5 M.2 cartridges for storage, and it'll hold 128 meg of cache, and the memory is up to 64 gig. Our other cartridge that we kind of like to use is this guy. It's an 8 or a 16 core processor, up to 128 gig of RAM, and a 3 M.2. So you put 4 of these in that box. The chassis is a 1U chassis. It's a ruggedized chassis meant to be installed out at a plant site. Okay, so this is where we're marrying IT and OT. That ruggedized chassis that we're putting these cartridges in can hold those OT device controller cards. So we have direct connectivity to those sensors if need be. If you don't want to use an IoT gateway, you can use this box alone. You have the choice. But this gives you and by the way, this server is taken from our Moonshot chassis. I don't know, some of y'all may know of our Moonshot server. It's a 4U chassis, and you can put 45 of these things in it for incredible density of compute. I know that DataStax Cassandra loves this box. It's certified on that. And so this also, the important thing to know here is this also runs ILO management. And this is what gives you the capability of your IT staff to do remote maintenance of these servers out on the edge. And that's a huge cost savings. Again, this is what the 4000 looks like on the left, because you can put 2 of those in the left, 2 in the right, and the 1000 is just a single cartridge option. Another interesting thing is that for machine learning, you can put actual full-size GPUs in those things. 4 of them in the 4000 and 2 of them in the 1000. So you have lots of, this is, where you would do your machine learning inferencing here out at the edge, and you would be connecting this up to some monitoring applications for maybe some video analytic feeds or something like that. And again, I mentioned the DataStax Cassandra certification. That kind of comes into play in your your fast data stack if you're doing open source. So this is kind of the new picture of what we look at, the edge being anywhere outside the data center. So we've kind of simplified that. These are some of the benefits of doing what we're trying to do here, and one of the big ones is your latency, of course. The closer you get to the source of data, the faster you can make analytic decisions, and some of the real-time decisions that you need to make can only be done out at the edge in the time required. And of course, you're going to be doing a lot of ETL out there. You're going to be reducing your network bandwidth and your upstream bandwidth of that data. And of course, that's going to reduce costs, because bandwidth is costly, especially if you're out on an offshore rig and you're sending this up over a satellite link. Threats. We have the capability even out on the gateway, in stage 1, where our IoT gateway devices are. We used to own a product called Voltage Secure Data, and now we spun that software division off to Micro Focus, and they now own it, but I'm very familiar with that product. And they have libraries that are just a few hundred KB in size, and that can be installed out there on those IoT gateways. You can actually protect that data all the way out on the edge as soon as it's developed and it's created. So our threat envelope is a lot smaller if you can do that. And the duplication, of course, with our ETL capabilities now, with the more power that we have out there on the edge, we're going to be doing a lot of ETL. A lot of analysis on what data needs to be sent back to the Hadoop cluster in the data center for persistent storage, or up to the cloud for archival type storage. Reliability, these are data center grade server cartridges. They've been around for a while now, and they're proven. They're going to, and there's, we can put 4 of them in a chassis and a cluster. So we have built-in redundancy. And of course, the compliance codes, that's kind of getting back to the safety question. If you're protecting the data, you're going to be meeting compliance. So these are what we kind of think of as the requirements of an intelligent edge. You're going to need connectivity, and we certainly have that with our Aruba wireless networking product line. I haven't mentioned much of that, but it's kind of operates in the background of this solution. You're going to have to be able to connect all of these devices, so that's what we would use there. And the compute, I've already covered the edgeline servers, and we have the elastic architecture for Hadoop, so we have the edge to core infrastructure required to implement this. And where we partner is in the control space with the national instruments, with the Hortonworks data flows, the other software vendors that we need to roll out this solution, because we realize that we need to have those kind of partners. We provide the infrastructure. We marry the OT devices for needed with the national instrument type devices in our products, and we certify them. And then we can roll that out. But this is where we play in the yellow stars there. So what this kind of looks like, I mentioned the OT cards that we put in our systems. That's kind of indicated there on the left. And we certify those to interoperate with our edgeline servers. And so what looks like this in the old days, where you have all of in this example, you've got a couple of wired sensors going out to a controller. And you've got it connected to some standalone compute for analytics off of that, okay? So what we're going to do is merge all that into the edgeline. This is also going to give us remote system management from the data center, from those guys up there that know how to do this, have done it for years. So you now have that out to the factory floor, that kind of management capability. So we're simplifying, and we're merging this into a much simpler package and easier maintenance. So essentially, you've got all these phrases. All of this deals essentially with data pipelines. We want to move data with the minimal effort. Just kind of remember this portion of it, the minimal effort. And this is a simplified view of that data in motion, where we're going from the IoT edge through some type of fast data pipeline, be it open source or be it packaged like in Hortonworks HDF. That would be there in the fast data area. So essentially this is like stage 1, stage 2, and then here on the right you've got 3 and 4 in the big data space. Okay. 3 and 4 can be merged. There's nothing set in stone here. These stages can move around and probably will move around, depending on where you want to implement your functionality. This is an example of where we're doing deep learning on the right with our GPU-enabled servers off of our Hadoop data lake. We're doing our training there, and we're developing models that we're sending back out to the edge for inference on the IoT edge. And that all goes through data pipelines. This is the easy button. That's the more complicated button if you want to go open source. So you kind of have the option there. A lot of the large customers have the staff on hand to do this, to implement all of these open source packages. But in a lot of our white papers that I've seen at HPE use open source. Hortonworks has done a very good job of keeping data flow a secret. So that was one of the reasons. We're actually working together now on a POC to get data flow certified on our edgeline. NiFi and MiniFi and all of this is already certified on edgeline. It's just that the package I want to have the whole package installed and have that validated as well. So it's kind of just a formality, but since Dataflow incorporates Minify, NiFi, Kafka, Storm, and all those products, we essentially already have it certified, if you will. Another bit of an example here, kind of showing you where some of the functionality might fit in our forward stage model. In this example, we've got stages 3 and 4 out there now in the IT system, in the IT world, in the data center. Our edge line 1000, 4000 is going to be out in stage 2, where I kind of showed it earlier with the gateways functioning out there, right there at the edge, at the sensor connector area. This is a bit of an eye chart, but I thought this would be probably the most low level that I could show some of this stuff. These are the sensors at the bottom, and if you'll notice all of these different dotted lines, you'll see that there's all these sensors. Some of them require different types of connectivity, some wireless, some wired, some different protocols, all going up to our IoT gateway. So, I like to think of the IoT gateway as maybe a converged protocol device, because you've got all these different protocols going into it and one coming out of it. So it's simplifying the protocol deployment, and you're merging and doing your basic ETL there as well. The next stage up at 2, you've got your, this is still on site, maybe at the control shack, as I mentioned before. It could be out at the plant site, just depends on how you've got your setup work out. These are all ruggedized devices. It doesn't require air conditioning. But that's probably where we would set up the NiFi cluster. You would probably have your early analytic BI tools set up there and your monitoring stations. All of that data could, again, go through an ETL process, and the necessary data for persistent storage could be sent either to a HTTP platform or to the cloud. Never know when these things get completely built out. Okay, we're starting to kind of get into now the Hadoop platform portion of it in the IT data center, which is the other piece of the equation from the intelligent edge over to the hybrid IT side. What we've done there is, again, the Aruba is for our connectivity, and our platform will be the edge line at the intelligent edge. But at the core, we're going to run our, we recommend that we run our elastic Hadoop architecture. And I don't know if you've been by our booth or not, but there's a virtual rack on the right side of our booth that shows this in a very pictorial form. What we're doing here essentially is separating compute from storage. The storage being showing up here on the bottom, and you can do storage tiering as well on it. But up at the top, you've got different types of workloads being serviced by different purpose-built type platforms, okay? That's what's different about traditional Hadoop, where all of the server nodes are the same, the worker nodes, and the compute and storage is installed together on those servers. When you install the compute and storage separately, now you get the option to do purpose-built type servers and run your workloads on special types of servers meant to make those workloads perform the best they can. That's all made possible by using Yarn node labels. It's simply a method of tagging your servers with a metadata tag, and when you submit your jobs, you just mention that tag, and that's where it runs. That runs on those servers with that tagging. So if you've got a Spark workload, you'd probably run it on a set of servers with a high core count, a lot of memory. If you've got the machine learning workload, you're going to run those on your GPU-enabled servers. If this were running in a traditional architecture, and a year from now you decided, okay, I've got to run machine learning now, but your cluster doesn't have it, you're going to have to go through every worker node in your cluster, pop the hood, and put a GPU in it. That's just the way the traditional architecture is. There's no forgiveness of mistakes. Once you get that configuration determined and you implement it, and you roll that out rack after rack, that's how it's going to be until that cluster goes into life. So it's difficult to recover from any kind of oversights on a traditional cluster. What we can do here is just put a new tier out there and label it with a new label. So we like this architecture. Most of our customers, it's very difficult to argue against this. We do lose data locality, which is supposed to be the secret sauce of Hadoop. We make up for it by using a 25 gig network. Okay, we're running 7,200 RPM drives on these servers, so they're 100 megabits per second as the throughput. It doesn't matter if you put that smart array controller on a fast 6 gigabit or gigabyte per second PCI bus or a 25 gig network. Neither one of those is going to be a bottleneck to that slower drive. So that's how we get away with losing the data locality. Okay, we just speed up the network. These are some of the types of devices that we can use in these different architectures. Again, at the IoT, you've got the Apollo 4000, Edgeline 4000 at the top, the Edgeline 1000 at the bottom. For fast data, we've got a white paper out there where we're doing the SMAC stack on Synergy. That's our blade chassis. We have a white paper developed with that solution. The third box row there is our kind of our traditional elastic architecture. That box at the top is an EL2000. It's a 2U chassis that holds four server-like blades in the back of it. It's actually the bottom server of our HPC line. So it's been used for HPC for a long time. So we get incredible density by doing that. We get 4-to-1 density over a traditional Hadoop worker node configuration with this server. That's a 2U chassis. Okay. The box below it is another 2U chassis, and that's an Apollo 4200, and that's what we normally use for our storage tier. You'll notice it's got two 12-drive shelves. They're all hot pluggable. What you don't see there is there's 4 more drives in the rear. That thing holds 28 large form factor drives. What's cool about it is with Hadoop, it requires large form factor for cost reasons. A 2 terabyte small form factor drive is about twice the cost of a 2 terabyte large form factor drive. And Hadoop's all about storage. So you can really price yourself out of the deal really quick trying to go with small form factor. I don't know of anybody that has easily accessible hot pluggable drives like that box. I don't think our competitors have that. So we really like that box. It's perfect for what we use it for with the elastic architecture. And it can even be, we usually use 4 terabyte drives in that thing, but it can be used as an archive tier and a tiered storage solution for on-site archive with 12 terabyte drives. Now on the bottom right, if you really got a lot of data to store on the archive, we can use the 4510 Apollo, which has 60 large form factor drives. So this is our cloud-like experience. We can essentially implement a cloud on-prem with this type of architecture because of the dense storage capacity that we have. And on the top right is our Apollo 6500. That's a 4U chassis with 2 drive shelves. They're full width drive shelves. Each of those drive shelves holds 8 GPUs, up to 8 GPUs. So you can get 16 GPUs in 4U. So that's our machine learning. That's our machine learning box that we like to use for training our models. And that's just kind of another view of it. We do traditional architecture as well. If you do want to do that, we have the DL380, which we usually, and when you can actually use the Apollo 4200 in a traditional architecture. Just put more cores in it to match the higher spindle counts, and you can do well with that box as well. Okay, we have a service practice that offers this as a platform as a service. So these architectures can actually be delivered as a service and managed by us, if that is so required by your company. This is kind of how it works. We design the solution based on your requirements, and the green boxes over here on the left are kind of the flex zone, if you will, where you can flex your compute up or down as you so require. and you're only going to pay for what you use. And it's all managed. It's on your site, either your site or your colo, but it will be managed by us, okay, and installed. So that's an option as well. So in summary, I want to leave some time for questions. These are kind of the overall items that I wanted to point out today. The workload optimized architectures like our traditional and elastic architecture for Hadoop. The new generation of data and analytic platforms, our edge lines, our intelligent edge lines, as you can see here. We try to partner, and we are partnering with lots of partners. We're partnering with HortonWorks to get a data flow proof of concept developed right now as we speak. Everybody seems to be pretty excited about that. We partnered with National Instruments on the OT side to enable all of this low-level and mingling of products to get actually done. I mean, you can't do it without that integration with the OT products. So that pretty much wraps that up. If y'all have any questions, okay, well, if y'all have any questions, come up and ask me, and I'll let y'all have the rest of your day. Thank you.